Welcome, everyone. My name is Serhat. I'm from Turkey. There are a lot of Turkish people around here, and there are also a lot of AWS community heroes. I'm one of them. I'm also helping, I'm not sure if you are familiar with DevOps Days events, but I'm also one of the global co-organizers of DevOps Days events as well. So I'm working as a technical evangelist at Atlassian. I'm particularly focusing on Opsgenie product, so they acquired us a year ago. So I'm still working specifically with the Opsgenie team. That's all about me, but today we are going to talk about something a little bit different, something that we are interested in. We are interested in exploring in Opsgenie. It is serverless, particularly AWS Lambda. So we've been working with serverless technologies, various serverless technologies, but also specifically AWS Lambda for the last 4 years. Like since it is released, like considering its release like 6 years ago, so we are one of the early adopters of serverless competing. So at the same time, there is also serverless conf happening in New York. So I'm expecting maybe Tim Wagner, so he's coming back. Maybe he's going to smash other racks, but we'll see. Not going to happen here, definitely, today. So who thinks serverless is a buzzword here? Anyone? OK, no one, right? We are in an AWS conference, OK. So I think serverless is still kind of misleading, and people understand different things, and that's kind of OK. But I think what is important is looking at the why. We want to understand the reasoning behind serverless, right? So why is always important, more important than what. I think it is as simple as like this sentence. There is great inefficiencies in how we operate software today. There's also great inefficiency in how we develop today, but I don't think serverless really solves that. Actually, it makes it a little bit worse. So I'm going to talk about some of the bad things as well. Two of the biggest problems, there are a lot of idle computing resources, especially like if you work with enterprises, you will see that there are a lot of computing resources just lying there empty. No one is using them. So AWS Lambda kind of solves this problem. It also reflects the pricing part of it. But the other problem is developer productivity. So there are a lot of people in our company, mostly called operations, working on the operations stuff. So we outsource some of these to AWS, not everything, but some of these, so that we can actually focus on what is important for us. And specifically for us, Opsgenie, so first let me tell you what we do. So we are a modern incident management solution for operating always-on services. So we help you with your alerts, on-call scheduling, escalations, and all. So if you think about it, us being down is kind of a big deal because we help. We let our companies know that when there is an incident, so we notify them, right? So it is kind of one of our like when we develop a new feature, first thing that we do is like looking at the reliability, how we can make this better for our customers, so that we are not down. So one of the things that from the early on, even when our co-founders started the company back in 2012, is we made this decision to adopt AWS services, fully managed AWS services as much as possible. So when we are evaluating a service, if there is a good option within AWS ecosystem, we try to use it. And there are a couple of reasons. First one, obviously, we don't want to spend a lot of time. There are things that are not related to our business, so we want to outsource those to AWS if possible. And it is really hard to find DevOps engineers, whatever you call them, right? Experts on specific areas. Considering our engineering team is in Ankara, Turkey, for example, it is even harder than London. It is less expensive, but still it is harder. And also, your team cannot be expert on everything. Comes to the same conclusion, we want to outsource some of the things. And so we use a lot of different various AWS services, DynamoDB, SQS, Lambda, Aurora, EC2, ALB, Route 53, SNS. There are a lot more of those. So just going over the history of our journey. So in 2015, we started writing small-scale custom integrations. At this point, we started leveraging AWS Lambda to help our customers integrate with our product. And it is actually a pretty valid use case even today, but AWS also created this new service, right, Event Bridge, specifically focusing on this particular feature, use case, because it is a pretty valid use case for everyone. It works quite well for us. We still use and recommend our customers to use AWS Lambda while integrating with our product. First, they don't pay anything if there is no alert, there is no need to trigger our product, or they just don't create an EC2 machine. Just, sometimes it's also, for a lot of people, it's hard. There's no like idle HTTP endpoint waiting to respond to incoming requests. It just works. So it's one of the best use cases. So we saw the first production usage in 2016. So we started using Lambda for asynchronous things, not, let's say, business critical jobs. I'm going to show you this example later. For example, scaling our DynamoDB tables. So AWS DynamoDB Autoscale kind of has some limitations that we don't like. So we wrote our own scaling for DynamoDB, and in 2016, that is AWS Lambda became one of the important parts of our stack. So in 2017, we want to take this into one step further, as we saw AWS Lambda growing, and adding new features every year. Just to give you an example, when we first started the concurrent execution limit, I'm not sure if you are familiar with the concept, but there's a limit that you can run. There's a formula, but simply there is a limit that you can run AWS Lambda functions. How many Lambda functions can run concurrently at the same time. And it was 200 back at the time. It's now, I think, 3,000. So you can see like how AWS is increasing the limits and improving the capabilities of AWS Lambda. So we wanted to leverage that, and we decided to create this new feature called Service and Incident Management, which are connected to the rest of our applications. Most of the things here are called from the other EC2 machines via the SDK that this team provides to trigger our Lambda function. But also there is a public API that works with the API gateway, but I think we are changing that because of some problems. And also we are in a transition to integrate with Atlassian. So that means we are going to use more Kubernetes. So we had this experience. Now I'm going to talk about a couple of takeaways from this experience. So the first one is serverless doesn't remove the need for great engineers. We sometimes, we hear this all the time, right? Serverless, it is less ops, it is no ops, but still we will need a lot of people that know how to use AWS Cloud properly. And this is just an example from, for example, Yankui's presentation. I don't have the whole picture of our serverless parts, but just to show you an example of how complex it can get. I mean, it is really hard to track what is going on in a fully serverless application. And I doubt that there are many fully serverless applications, but when you want to create a big application with just using AWS Lambda, it will involve a lot of different AWS tools, and it can get pretty complex, especially considering there will be a lot of small functions. And there is a really steep learning curve for going fully serverless. And for those of you who have experience with Lambda, I think knows this. Well, it is pretty easy to deploy your first function, but when you actually want to create something useful, create a connection between your functions, between your existing tools, it can get pretty ugly. And obviously, microservices is hard, and when you use a service like AWS Lambda, you are kind of forced to do microservices from the beginning. And it might not be the best choice at the moment, but you are forced to. So development environment in AWS Lambda has a lot of problems in that sense. So it makes it harder to create microservices. There's not really great tooling around Lambda. Still, there are a lot of tools, but I think we need better tools still. So a couple of things that you should be aware of. So first, a lot of teams aren't really experts in creating event-driven architectures. We use Java, for example. We use Java for 99% of everything in Opsini, except like a couple of small things and SDKs. So Event-driven might be a new thing for your team. Inter-function communication is complex. Again, you have to figure out whether you want to use API gateway. It might be expensive and might be some limitations. Or you want to use SNS, SQS, like how do you want to create the communication between your functions? There is no one best way of doing this, and it might be complex if you are not familiar with all this tooling. And functions should be idempotent. I mean, there are a lot of ways. To look at this issue. But for example, for us, one of the things that we do to ensure that we don't process the same request multiple times. So the reason for this is AWS might trigger your function with the same payload multiple times with the exact same payload. And we saw this like 3 or 5 times just coming over the same payload. So we don't want to process the same payload over and over again. In this case, you might want to consider putting a cache and checking if you already processed that. And then you add the Redis and check that every time. So it's kind of a problem as well. And your functions need to be stateless. So you can keep your data for some time and cache it on your local. But obviously, functions are going to be destroyed at some point, even though they keep them for some time to improve the cold start effects, to reduce the cold start effect. But you have to think stateless and persist your data to a persistent storage every time. And even milliseconds matter. I mean, when we use something like, let's say, Spring Boot, we don't really care about a couple of milliseconds. But when you go into a place like Lambda, a couple of milliseconds actually matter because you are going to see the cost effect on your bill clearly. So you have to start thinking about performance more and more within AWS Lambda. So, and the second takeaway is serverless is less of. So we just talk about this a little bit. I want to give you an example. So we had an incident. I mean, we had a couple of incidents before. AWS Lambda is very generous in giving back the money. I mean, they give the money back most of the time. In this case, for example, they didn't have to, so we really used the computing resources with this incident. When you just forget about an EC2 incident, it is easy to see that you really didn't use it, right? But with Lambda, we really used it. So one day. We had this environment set up in a development environment. We didn't have alerting for pricing. So there was this function called incident monitor log, basically making a request to Graylog, sending the logs. And Graylog was down, so request fails. Request goes to a queue, to queue. And after 5 minutes of retry, again, so this function works for 5 minutes. At the time, the limit was 5 minutes. So it works after 5 minutes. It ends up in the queue, and there is another function polling the queue. There was no SQS trigger at the time, so there was another function just polling the queue and just running the function again. So basically, it ends up in a infinite loop, and runs for 2 weeks, consuming all the 3,000 concurrent execution requests all the time, and it ends up with $4,000 of bill. Just for that part. So what are the learnings? First, you should avoid infinity tries within serverless. Again, it is a different environment. You have to know it's how to use it, right? So one of the important things is you should avoid infinity tries, and you need to monitor and alert for pricing. But there is no pricing metric for AWS Lambda, so you have to kind of probably alert for the overall pricing and go ahead and check if there's an anomaly or not. And also, you should think about CloudWatch cost and sample logs and metrics as much as possible, because when you think about Lambda costs on paper, it might not be a lot, but if you are using, for example, CloudWatch, writing a lot of logs, in our case, CloudWatch costs way more than Lambda costs, for example, you have to think about those as well. Just to give you a couple of reasons that serverless is less ops, not no ops, you still have to build your delivery pipeline and development strategy. And the bad thing is there is no one best way of doing these. And there is cold starts. So we were using VPC. We had to use VPC, and basically the cold start time doubles when you use the VPC, but they I think fixed it. I haven't tried it yet. They fixed the problem, so it's no longer an issue. So AWS Lambda is kind of marketed as an infinitely scalable service, but we had reached the limit a couple of times, and when you reach the limit, you get throttled. So you have to make a request to AWS and ask for an increase in your concurrent execution limit, which takes about at least a couple of days. And monitoring has to be a first-class system because you don't know what is going on with your Lambda function, and considering you have multiple tools working together, it's kind of different. You need a different way of monitoring. So earlier, my friend Emrah talked about chaos engineering, so he's from Tundra. So Tundra is actually born within Opsgenie. So we were doing a lot of things with Lambda, but there was not really a great solution to monitor your Lambda functions. So internally, we created this tool. Later, it is named as Tundra and became a separate company, not related with Atlassian. But at the time, there were many reasons to create something internally because there was no way to attach an agent, for example. We were using Java. None of the existing monitorings worked. So if we want to know what is really going on within a function, it takes more time. And we want to debug it, and see what is happening, like which parameters we are sending a function, kind of basically application performance monitoring. We didn't have anything, right? So we had to build this. There was also too many moving pieces, so we needed what we call today distributed tracing. So how our request goes through different functions or different AWS tools. And again, even how to send the monitoring data is a discussion point because traditionally, monitoring data is sent through HTTP requests, but if you do that with Lambda, especially on production, there are a couple of problems, right? You can, your request will increase the response time. Pricing is, okay, that we accept, but it will increase the response time to your customers. And also, if it fails, it might result in failure in your function as well. So what we do is, even though it is just a little bit slower, we write everything to CloudWatch, and there is another Lambda function listening to that CloudWatch logs and sending the data to Tundra. So this is how they do it now. So again, there are a bunch of other reasons to need a better tooling, suitable tooling for Lambda. So that is why we had this tool. So the third takeaway is about pricing. So serverless is usually cheaper. And so some fully managed services which AWS recommends using, like API Gateway. I mean, we see blog posts all the time about API Gateway, but it is really expensive. And so what AWS recommends these days, if you are not really using the advanced capabilities of AWS API Gateway, you just use ALB, right? Just use Elastic Load Balancer, Application Load Balancer. And it's just cheaper, and it just works pretty well. It's easier to use. So Lambda cost isn't the real cost by itself. You have to be aware of that. But just thinking about the tooling costs, obviously isn't the right way. So for example, one of the ways we use Lambda. So this is deprecated about a year ago. And the reason is when we did this, there was no global DynamoDB tables, but we needed to replicate our tables across different regions, not just availability zones, for availability purposes, reliability purposes, just in case if there is a region-wise failure within DynamoDB. So we needed to replicate our data in real time to another region, and what we did was just write a simple Lambda function, just 20 lines of code, and terabytes of data coming through and replicate it to another region just in a couple of seconds. So it's pretty easy, and it might cost on paper a little bit more than EC2 machines if you choose EC2, but then you have to deal with all the complexities of Kinesis consuming the library, and if you get a lot more requests, you have to scale your EC2 machines. There are a lot more things to worry about, so it's kind of harder to monitor, set up, and operate overall. So it's really easy, just 20 lines of code, it just works. So a couple of things about the pricing. Obviously, there is a free tier, and the requests are based on 100 millisecond based pricing. And Again, it's not just about pricing, it's also about the engineering time. It is probably our biggest cost. And total cost of ownership is also important. No initial investment, you just use it. If you want to create something fast, it is the best way. And there is less maintenance cost overall. And again, you are probably not Spotify or Netflix, so it depends on where you are on your journey in your business. But you probably don't want to focus on these a lot on the technical issues, but just rather on your core business. So serverless can help in that sense, even if it's a little bit more expensive in some cases. Usually it's cheaper, but in some cases, if it's expensive, probably it's okay. So we talked about like some of the use cases that are really no-brainer to use AWS Lambda. But obviously, serverless helps with a lot more. So I'm going to show you just a couple of examples, use cases from our usage. So the first one is the integration example, for example. In this case, it's just Slack. So there is a message going to Slack, and Slack can make an HTTP request to your API endpoint through the outgoing webhook. So you have an API. We have an API endpoint with API gateway service, and that API gateway service will direct to the payload to Slack alert creator Lambda. So within the Lambda function, you can do whatever you want, right? You can just go at your Elasticsearch, for example, request some data and attach and get it, and just create the alert, for example, with more context. Or if you want to just create the alert, it's just easy with just use the SDK and create the alert with just one line code, right? It's pretty easy. Do whatever you want. And the best thing is it will only cost you money if you just write the Slack message. So it's not working if you don't do any requests on Slack. So that is the best part of it. And it's pretty easy to manage and deploy as well. And one of the things I talked about is DynamoDB autoscale and table migration. So we use a couple of Lambdas to manage those processes. So this is the old logo of Opsgenie on the right with the orange. It's not blue. So we have this autoscale Lambda. So we can trigger it in a couple of different ways. And one way is to check the Amazon CloudWatch logs. And if there is an anomaly, kind of like different things going on, we can increase the request or decrease the request. And it usually comes through the DynamoDB threshold alarms through CloudWatch. So if there's an alarm, we trigger the Lambda function. We connect the Lambda function CloudWatch through CloudWatch events. It's triggered, and we update the DynamoDB table. And in the meantime, there is another Lambda function, like DynamoDB alarm setup Lambda. So if we increase the DynamoDB table, DynamoDB table's read or write capacity, for example, we have to update the alarm as well, so that we don't get false alarms. So there is another Lambda function doing just that. And in case we want to do table migrations and increase the limit manually, we have a Slack function. We have Slack integration. Just you write a command on Slack and just make a request. Slack makes a request to Lambda, just like the previous example. And within the DynamoDB config table, that Lambda function updates the config table. And config table is connected to the same autoscale Lambda function through the DynamoDB streams trigger. So it will just work the same way and update the table accordingly. So this is the example of a, let's say fully featured, not fully featured, but basically a feature, kind of big feature, just working with Lambda. There are a lot of different functions talking with each other, as well as they are mostly triggered from other services that they are working within EC2 machines. There are also a couple of Lambda functions that can be triggered through API gateway. Lambda functions communicate with each other through SNS messages. And we did a couple of things through API gateway, but authentication authorization usually is done through another Lambda function in this case. So a couple of more FaaS, function as a service, serverless, is great for connecting stuff on the cloud, and that is why we are seeing more specific services just focusing on this one. And if you have something event-driven, and most of our workloads are event-driven, it can easily be done with function as a service tools like AWS Lambda. And now there is support for bringing your own language. So at the time, we had a hard time, like we wanted to use the newer version of a language. We really couldn't, but now you can if you need it. And even API Gateway now has a WebSocket support, for example. And remember, this is really important. The goal is not to use serverless. And if there is a more specific service that is, helping you do what you want to do, just use it. Because our goal is to create customer value, not use serverless. And there are a couple of other commonly used use cases. We have we have some of these use cases working with Opsgene as well. We use Lambda also a couple of for ETL jobs. We built a couple of APIs. Most of our ChatOps commands are basically work with AWS Lambda. There is one plus. So we often hear about vendor locking, right? I think vendor locking is often a myth. I mean, if you aren't working for a government, I'm not sure how you would justify spending a lot of time learning different clouds and basically working with them together. So I think this explains the phenomenon really well. Obviously, we should still assess potential risk and impact, but there is no cloud provider that increases prices or just stop working on these kind of important products. Building abstractions is time-consuming and counterproductive. And obviously, there is the loss of opportunity that is probably the biggest cost. So we talked about still needing great engineers. We still need to architect our application in a way that it works reliably. And obviously, there is no such thing as no ops. There is less ops. We outsource a lot of things to AWS, but we still need to do a lot of things that what we call operations. Lambda usually is cheaper, but we tend to ignore the cost of opportunity loss and cost of our engineers. Think about them as well. And you can do a lot more use cases than just connecting stuff on Lambda. It might require some expertise, but it is really possible, and AWS encourages it. And vendor lock-in is probably not your first concern, so think about that if you are spending a lot of time on it. So a couple of things. Customer really don't care if you run on virtual machines, containers, functions, or whatever. When we release this feature, I mean, they care about response times, for example. They don't care about that we use Lambda. They care if their solutions works reliably, their solutions is always on, fast, and user-friendly. They care if you deliver new features fast. And if you haven't read it, I really recommend reading this research. It doesn't just talk about the hype, let's say. It talks about real-life use cases and explores the advantages and disadvantages of serverless competing solutions like AWS Lambda. And it all comes down to this conclusion of serverless competing will become the default competing paradigm of the cloud era. Thank you very much. That's all from me.
We've got time for a couple of questions, if anybody has one. Oh, one right here.
And I will be around after the talk, so you can.
I've got two, but maybe I'll ask you one after. Thanks for the talk. You said Lambdas can repeat requests that come in. Yep. What events was that from? Like, what was triggering it? Sorry, what were the triggers?
I don't exactly remember, but I know that it happened for multiple different triggers as well. Like, it's not just one specific, let's say, DynamoDB streams. I remember it is happening for different triggers.
Okay, thanks.
I mean, it can happen, so you have to. I mean, they also state this clearly on the documentation. It's no secret, but I mean, these are the things that I think AWS Lambda promises us to not worry about. In the end, I understand that they are still working on these things and improving these things, but I mean, we still have to know about these and try to improve and talk about these things.
Anyone else? Yep.
Thanks for the session. So my question is on the concurrency. So you mentioned that it's not infinite. I think it's by default 1,000 per account.
Sorry, I can't.
Concurrency limit on the Lambda functions. The scale on the Lambda functions.
Scalability?
Yeah.
Okay, so
So my question is that in cases where we get a lot of throttling issues on Lambda functions, so what is your suggestion to use?
So what we did, so we had this, I think, couple of times in just a week. We tried to figure out what is causing it first, because normally we weren't really close to hitting the limit. If we were, we could just talk with AWS and they would increase the limit easily. If they can see, so when you talk with them, if you want to increase the limit, if you only have like a couple of spikes, they probably want to see what is happening there and want to solve it before increasing your limit. So in our case, there was something like that. There was a spike. Obviously, we expect AWS Lambda to cover those spikes. That is one of the promising things about AWS Lambda, but there is no service, obviously, with no limit. There are limits for everything we use. So that's, yeah.
Okay, maybe one more before coffee? Or are we all done?
Yeah.
Okay. Oh, one in the back from Anton.
Go easy on me, Anton.
Thank you very much for really good slides, especially about microservices. Was awesome.
Yeah.
I have a question. So you definitely have a lot of different Lambda functions and different serverless resources. How do you organize it from code point of view? Like, do you share code between different functions, or maybe you use Lambda layers? Can you talk a little bit about that? Because if we have one function, it's easier.
Yep.
Like, it works on my machine, everything fine. Yep. But if I have 50 functions, what are practices?
So I can tell a little bit about how we did that. I haven't been working with the team for the last 1.5 years. So I think some things might have changed. But we have a Java. We use Java with AWS Lambda. So we have one repo for all our Lambda functions. We share a couple of core libraries, but we basically have different packages for each Lambda function, and we can deploy them separately, but they share like a couple of different packages underneath. So it is really, I think that is like one of the reasons, one of the things AWS Lambda, why AWS Lambda is kind of hard to get in and hard to be expert. I mean, there is no real best practice in how you want to organize your Lambda functions. It can even change between different languages. For example, if you want to care about package size, it can be an issue in Java. So you might want to use something like Lambda layers from the start, because if you share a lot of code, the package size will increase. They will also affect your testing time, deployment time, and everything. So for us, we shared a couple of things, but we had like 50 different functions within the same Git repository, within different packages. So we were able to deploy them separately if we wanted to. Yeah.
Okay, great. Thanks again to Serhat. Give him a round of applause.